Guys, welcome back to my YouTube channel. Here we are discussing the most asked Google interview questions. So as we have sorted the Google interview questions according to the last 6 months data, and today we'll be solving this parallel courses question. So let's go into this question. So this question states that you are given an integer n, which indicates that there are n courses labeled from 1 to n. You are also given an array relations where relation I is equals to previous course I and next course I, representing a prerequisite relationship between previous course and course next course. Course previous course has to be taken before course next course. So there is one relation given, and it represents that in order to go to next course, we must first complete this previous course. So for each of these courses, some prerequisites are given. So in one semester, you can take any number of courses as long as you have taken all prerequisites in the previous semester for the courses you are taking. Return the minimum number of semester needed to take all the courses. If there is no way to take all the courses, return -1. So in this given example 1, so the relations is given as 1 and 3. So in order to reach to the course 3, we first need to complete 1 and 2, 3. In order to reach to the course 3, we need to complete course 2. So n is the total number of courses, and for this answer will be 2 because in the first semester we will take course 1 and course 2, and then in the next semester, as a prerequisite for the third course has been completed, so in the next semester we can take the third course. So we require at max uh, like 2 semesters. In 2 semesters only we can take all the courses. Now let's take the example number 2. So in this we can see that there is one cycle forming. So this is kind of a deadlock situation in which one of the course is a prerequisite for another, and that another is also a prerequisite for the first one. So in this we would not be able to complete all the courses, so that is why we are returning -1 in such cases. So I think you have understood the problem statement, and let's go to the explanation part of it. So if we see, let's don't take this example for now. Let's just take this example. So initially, suppose this is the graph given to us. So in order to complete course 2, we need to complete course 1, and in order to complete course 3, we need to complete 2, 4, and 5. So what we'll do is we will maintain a queue, and this queue will contain. So we will solve this question using BFS technique, and what we'll do is we will store a pair of intent, and in each of these element, first we will store like which course like we are referring to, and the second element will contain how many semesters we need to complete this course, and we'll also, so initially you can see for 1 4 5 we require only one semester. So for the courses which need only one semester, we'll first insert all those semesters into this queue. So 1 1 4 1 and 5 1, this is inserted. So initially this maxim contains our final answer. So how many courses will we require to take all the courses? So initially our max SAM will be 1 because initially we require one course. So then we will just pop out each and every element out of this queue, and for each of the element we will analyze its neighbor. So for first the neighbor will be 2, and when we are analyzing the neighbor, we will also see the count, like how many prerequisite for this course have been completed. So what we'll do is we will also maintain one more vector array, and in that we'll see like suppose for course 2 we require one course to complete. For course 3 we require 3 course to get completed. So like when we'll explore the neighbor of 1, then we will come to 2 and we will see that one course has already been done. So as the degree of 2 was 1, so it will be reduced by 1 and it will become 0, and hence we can push our answer into the queue. So initially it was 1 and one semester is more needed, so we'll push our answers 2. Then we'll come to 4. So for 4, like initial degree for 3 was 3, and when 4 will come, it will be reduced to 2, but it will not be 0. So all the prerequisites have not been completed for 3, so we will not insert 3 in the queue. Then we'll come to 5. Then for 5, also it will reduce the degree of 3 by 1, so now the degree will be 1 of 3, but still it is not 0, so we will not push into the queue. So now we'll check. So now all these 3 elements have been gone out of the queue. Now this element will analyze and will here update the maxm as 2, because here 2 is coming, so maxm will be updated to 2. And for 2, we'll see its neighbor is 3, and now for 3, this degree will become 0 now, and hence we will push our 3 to queue, and we will increase the number of semester from 2 by 1, so it will become 3, and so this will also be popped out, and when 3 will be popped out, then we will also see, then we will update our maxm to be 3, and yeah, then I think queue will become empty, and we have also covered all the courses. So yeah, our answer will be 3. So courses covered are 5. We have covered each and every course, and our max sam will be 3, so we will return max sam. So how this is how our algorithm will work. Let's see in the case where this cycle is also present. So now we are ignoring this first one and we are seeing this second one. So in this one, initially in the queue we will push 1 and 1, and after that 2 will not get pushed because initial degree of 2 was 2, and 1 will reduce the degree of 2 by 1, so it will be updated to 1. And since all the prerequisites for 2 have not been completed, so we cannot push into the queue, and when this will be popped out, then queue will become empty. So our courses, only one course has been covered, only this course has been covered, these courses are not covered. So our course covered, this counter is 1, and in this case hence we will return -1, because we are not able to cover all the courses. So I think you have understood the algorithm. Let's move on to the code part of it. So we are doing the same things in the code also. So initially we are defining one in degree. In degree will contain the counts which you are keeping. Like for 2 the count was 1, for 3 the count was 3, like 3 courses are required to complete 3. So in degree is that variable, and adjacent will store like it will store the graph. So we'll take our relations array which is given to us, and first of all it is given in one base indexing, so we'll reduce each of these two values by 1, and then we will insert this relation into our adjacent graph, and we'll also increase like as this relation is ending at 1, so we'll increase its in degree by 1. Then we will declare one queue, and as I mentioned here first element in queue refers to course number, and second element refers to the max sam taken to complete that course. So first element is course number, and second element is max sam required to complete that course. So initially we'll check if in degree is 0, means there are no prerequisite for that course, so we'll insert that course number, and we'll also insert 1, because only one sam is needed to complete those courses. So these are pushed into queue, and then we'll initialize our variables. Course is covered, like how many courses we are covering, and then max sam is, this is our final answer. So we'll check, like we'll pop out the first element and then we'll update our maxim answer, and we'll also increase the courses covered by 1 here, and then we'll run a for loop for the adjacent courses, and in each of the adjacent courses we will decrease the int degree by 1, and we'll check if the int degree becomes 0, then we'll push this course, and we'll also push the maxim required, and we will increase its value by 1 from our current maxim of the current course. So yeah, this way we will keep on updating our maxim variable, and if courses covered becomes n, then we will return our maxim. Otherwise, if courses are not covered, if courses covered is not equals to n, as it was in our second case. In our second case, courses covered was only 1 instead of 4. So in this case, like there is one cycle present, so we will return -1. So in this way, this is the code explanation. So I will attach this solution code in my comments, and I will also add the problem link and problem description in my description of the video. So I hope you like my explanation and you have understood the solution to this problem, parallel courses. Stay updated for more important Google interview questions, and we will also be covering some more important lead code questions in future. So yeah, do like this video and subscribe to my channel for more upcoming useful videos. So yeah, thanks and have a nice day.